Hi guys, welcome to part 1 of our Module 2 lecture. The topic for this lecture is going to be measures of central tendency and variability. So this week's major concept is looking at the construction of the normal curve and what different statistical calculations can contribute to the curve's characteristics. So in order for that part, which is our second part of our module, for that to make sense, we have to talk about measures of central tendency and variability. Most of you have heard terms that are related to these measures before, such as mean or standard deviation. But the organization of the lecture is kind of tricky because we can't talk about part 1 without talking about 2 and vice versa. So I'll try to go through the terminology first, and then we'll go more into the conceptual details later. So just to show you what the normal curve looks like, most of you have heard of this curve before by means of a bell-shaped curve. Okay, so it's called a bell-shaped curve because it looks like a bell. But in statistics, we also call this the normal curve, and it represents the assumed shape of a sampling distribution of a population. So you'll recall that last week I was saying, oh, we have to make sure we randomly sample people. That is an assumption that has to be met for every statistical test, and the reason being is that if you randomly sample a large enough group of people, when you plot out their values in a frequency distribution, it should relatively look like this normal curve shape, meaning that you've got very few people at the high end above the mean, very few people at the low end below the mean, and most of your sample kind of sitting around the mean of what we would think the population mean would be. So the mean, which we can see here, is a type of central measure. The standard deviation which is noted by the sigma, baby sigma value, that is a variability measure. When we talk about distribution shape, right, we're going to be making some frequency distributions next week. But generally how we make a frequency distribution is we say, what are all of the possible values that could be assumed by our measured outcome, so your dependent variable, and then you count how many times that value has occurred. Sometimes if you have ratio type data that isn't clean and cut into whole numbers, you can create like a histogram that creates bins that will contain a certain range of data, and then it just counts how many values landed within this little range. But we put that frequency distribution together, and we generally get the shape, right, or our normal shape. Now, this shape can be affected by several different factors. Usually, when we talk about distribution shape, we're looking at outliers, or we're looking for outliers to see if they've impacted the shape in any kind of way. So curve shape changes as a result of those outliers or extreme scores, which is another way that I'll reference them in the lectures. And the resultant shapes can either be positive or negative skewness or kurtosis. We'll go into more of what these actually mean in the next lecture, but I still wanted to mention them because we'll talk about how the measures of central tendency relate to these things. Okay. For our measures of central tendency, they are mode, median, and mean. So most of your algebra classes usually go over this type of thing, so these 3 particular terms shouldn't be necessarily too new for some of you, but I like to go through them one by one as a nice review, just in case you need a memory jog. Okay, but these measures are going to describe the middle or central characteristics of a set of data. So like I said, if we created a frequency distribution and we counted how many values occur at a given dependent variable outcome, whatever that may be within the range of outcomes we could get, we can plot those in a frequency distribution, like a bar graph, and then we can visualize or overlay a normal curve on top of that. And our measures of central tendency are basically just going to describe the middle section of the data. Okay, So going into the mode first, this is the value that occurs the most often. It's largely based off of frequency distributions, which we'll go into. You can do simple or you can do grouped frequency distributions. You can sometimes have a bi or multimodal type of variable. So when you plot, say, your dependent variable measure on the x-axis and your frequency is on the y-axis, we want to see how many times does a certain value occur. In a bimodal distribution, you would have 2 peaks. In a multimodal distribution, you would have more than 2 peaks. Usually in a unimodal, or what most commonly happens is unimodal, is one mode or one value that occurs the most frequently. Okay, so let me get my thing here. Okay, the pros to using the mode is that it's pretty easy to determine, right? We have a series of procedures that we can do in Excel to find the mode. Very, very quick calculation, and it's a really quick estimate of the center of the group. It's also a fair description of central tendency when the data is normally distributed. So when you've got that nice, beautiful normal curve, the most frequent value should be right smack in the middle or pretty darn close to that. The cons of using the mode is that it is a terminal statistic. Okay, so you think terminal or something is terminated, after you make that calculation, it stops there. So terminal statistics do not give us information that can be used in other statistical analyses. So in that case, if you were just trying to find the central tendency and you have normally distributed data, a mode might be a good option to use. The other con is that it disregards extreme scores. So it doesn't matter where that highest frequency occurs in the distribution. So it could be in the middle, it could be towards the end. We wouldn't know what is on the right or left of that value. So you could have a distribution between 1 and 10. Let's say that 5 is your mode, or your most frequently occurring value, and then you have an outlier of like 69 way out on the upper end or the right side of the mean. A mode of 5 isn't going to tell us that that extreme score exists. And sometimes it's important for us to know that outliers exist because they can affect our statistical analysis later in the game. So these are 2 cons as to why we wouldn't use a mode, but again, it's a very, very quick way to kind of get a general idea of where the center of your distribution is. For the median, this is the score that is associated with the 50th percentile of the data. So it's the middle value in a rank ordered list. So if we have a data set, we have to order values from smallest to largest, and then we can find the middle value within that set. If you have a sample size that has odd values in it, you have an exact middle score that becomes your median. If you have a sample size of n that is even numbered, you have to take the average of the 2 middle scores within the range. Okay, so it's, again, pretty easy to calculate. In terms of pros, it's appropriate for ordinal data, obviously because they're already ranked. However, you can use it in non-ordinal data as well. It's also nice to use in highly skewed data, right? So we mentioned the concept of skewness. So when you have an extreme score that affects other measures of central tendency, a median would be nice because it still counts where the middle of the distribution is, regardless if that extreme score exists or not. So in terms of its calculation, it's not affected by extreme scores. However, in terms of cons, it also disregards those extreme scores as well. So the calculation is not affected, but we still, similar to a mode, don't get much information about how big that extreme score is and how it might affect other calculations. The median is also a terminal statistic, so after you calculate the median, your analysis stops there. you can't really use that information in any other types of statistical tests. The mean is probably the most commonly used measure of central tendency. So it's the arithmetic average of scores. In other words, you take all of your data points, you take the sum of that, and then you divide it by your sample size or the number of scores that you've collected. It considers both the frequency and quantity of scores. So we're not only looking at how many values have we collected and how many times do they occur in the distribution, but we're also looking at the quantity or the difference between values. So we most commonly use this because it's the most sensitive measure of central tendency. And when we look at our pros, right, it's going to consider all of the aspects of our data. It has good sensitivity, specifically to when we have extreme scores, right? So obviously, if you're adding up values between 1 through 10 and you have an outlier of, say, 27, right, the average is going to go up due to that outlier existing on the outside of your kind of where your regular normal area would be for numbers that you should have expected to collect. Okay, so the mean would be sensitive to that big number, and it would draw the mean towards that big number. Okay, means are most appropriate for ratio and interval type data because those are numerical values that we can manipulate, right? Cons are going to be that the mean is affected by outliers. However, we can kind of take this into account when we're working with our data. We can test for outliers. There's a lot of different methods that we'll talk about how we can do that. But if you don't catch an outlier, that's where it could be problematic because then you get a skewed idea. I don't know why I thought that was funny. Anyways, you get a skewed idea of where the mean actually is, right? Because of that high score is affecting where the mean actually lies in your distribution. So I've given you guys a set of practice problems here. I have a help video linked in the PowerPoint for tips on how to run the calculations in Excel. We also go over how to run the calculations in our activity this week. But basically you're going to use this frequency distribution to calculate the mean, median, and mode. And then you can create a line or bar graph to represent your data. Okay, I'll then have you compare your results on the next slide. So if you feel like pausing or maybe you want to watch the video, try it out, see if it makes sense, and then check your work with the next slide, you can do that. Just to explain what this is here, okay, the number of pull-ups, let's say, is our dependent variable and the outcome that we're interested in seeing what the frequency is. So in this case, our number of pull-ups would be on our x-axis, and the frequency would be on our y-axis so that we're able to get kind of that bar. Or if you're doing a line graph, right, we can visualize if we have that peak in the center of our data or not. Okay, the frequencies are just how many times these values occur in the distribution. So if we're looking at people who completed one pull-up, we had 2 people do that. So the order of our, if we were rank ordering our distribution, it would be 1, 1. And if we had 5 people complete 2 pull-ups, it would be 2, 2, 2, 2, 2. Then we'd have 11 threes, 9 fours, 8 fives, and you build your frequency distribution in that way. When we do all of our calculations, what we should end up with is a mode of 3, which we can easily see from this frequency distribution. It is the most frequently occurring value. So you could have calculated that just by looking at the table. The median should have been calculated as 4. So that's the middle of our distribution, just based on how many values we have collected, right? And then the mean is 5.1, or should be 5.1, okay? All of these generally represent where the central tendency of our distribution is, right? But you can see that the mode and the median are less sensitive to the presence of this outlier out here. Okay, so the mean is more sensitive because it is pulled towards that outlier, meaning that this value has affected the central tendency of our distribution.